environment B. Number 2, slow deployment, because remember you are clicking through the console. I will still use myself as an example. So there's this time I was creating infrastructure and I was trying to create a web server of red and blue to see how they work, especially when one server goes down and another server has to pick up the work. So in the middle of all this, I started getting errors. Nothing was working. At some point, I even forgot what I did. I don't know where the error is coming from. So what did I do? Lucky enough, I had noted down every resource I had created. I went back to, I deleted all the resources. You can imagine the headache. And I had to restart again and document every step and every configuration I was making. Hours maybe. I spent 2 days creating that infrastructure. So because if you create environment A, you have to start again to create environment B from zero. You're not starting from, it is hard to collaborate. The reason why it's because most of companies work as a team. You're not working alone. So if, for example, I, Belinda, we are working with Brian, and I have created this infrastructure, Brian may not be able to know what I have done, right? He may not know what resources I have created and which configurations I have used. So it will be very hard for Brian to just maybe log in into the AWS console and know what emails and asking for configurations, which is a very tedious work of back and forth. If the configurations are not the same, then now let me ask you a question. When you are building a house, yes, let's take this scenario. You are building a house. Depending on your memory, that is maybe the lounge, where you will place your lounge area, where the kitchen will be, maybe bedroom A, or where you will put the bedroom A, the washrooms and everything. Which is easier, working on your memory or having a blueprint of that house? Let's engage. Let's engage. Kindly, what blueprint? Yes. Thank you, Afari. Yes, that is, having a blueprint is easier because a blueprint is something that you agree on, and everything is in agreement of what is being done. So you, as the owner of the house, the architect, the foreman, the workers, everybody knows where each and every room and where and each and everything will be placed, okay? But let's imagine that you're working on memory. And maybe the workers that you have decided maybe from next week, they are not, maybe they don't come back, they have found a better place to work at. That is, imagine you're working on memory. So what happens, if you bring new workers, they don't even know where to start, right? They don't know what you have done. Same to infrastructure. If I worked on a certain infrastructure in a company, and maybe I get fired, or maybe I resign and move to another company, another engineer comes, and I clicked through the console. Do you think that engineer will have an easier time trying to understand the systems? Do you think they'll have an easier time? They may not even know where to start from. Maybe they'll just open the console and they will freeze, because the only thing they are seeing is provisioned resources, but there's no documentation to tell them which system is which. Maybe they are the EC2 servers, they are maybe like 10, but for different systems. So they don't know maybe an infrastructure for mobile banking, which EC2 are for that infrastructure, right? But if you have a blueprint, even if something happens to that engineer and another one comes, they know where to start from. They'll go through the blueprint, they'll go through the documentation and know which services were used, everything, and also the code. If now we are talking about using infrastructure as code, they will know where to begin from, and maybe this engineer did 3/4 of the work. So the rest of the work, you can easily complete that work because you have something to check behind, okay? So if you're building from memory, it's lost, okay? But if you have a blueprint, the environment will be identical every time, shareable within the team. The team can collaborate easily, versioned and reviewed through Git and GitHub, reproducible anywhere. So you can build 3 environments at the same time. You can have the dev, the staging, and the production environment, okay? So you don't have to build infrastructure all over again for every environment. So here we are saying that IaC is your infrastructure blueprint. Any questions up to that point? Any questions up to that point? We don't want to leave anyone behind. Okay, so how do we define infrastructure as code? This is simply a way of managing and provisioning cloud infrastructure using code file or the console. So if you want to provision a compute resource, you do it through the code, same to networking, storage, databases, security services, everything, basically everything. You do it through the code resources. You can use files like YAML maybe to provision the CI/CD pipeline. Then also we have, like in our last session, for those who are in our last session where we talked about cloud infrastructure, we were looking at how the resources or how services talk to each other, okay? So cloud architecture answers the question was, what should we build? How does this question get answered? First, we design the architecture. So whenever you design the architecture, you choose the services that you're going to be using for that architecture. But now, how do we build it repeatedly? How do we build this cloud architecture repeatedly without having to start everything from point zero? The config as code. Then you automate the provisioning. We will look at that when we come. We will look at that when we come to the review, and then you deploy consistently. So even if you want, maybe you build a production environment, you can come back later and dev environment. So that anytime that you're trying to make changes, we can test it first in the dev environment before pushing the changes to production. At the difference between the manual clicking of the console and infrastructure as code. Then also we have the benefits of using infrastructure as code. This is like the totally opposite of using IaC. So you always have the same result every time, every environment. Then there is speed. If you provision this code, deploying it is very easy because it is just a matter of automation through the Terraform workflow, of which we look at that into detail during our demo session. Then there is repeatability. You don't have to build 3 environments. You just need to create one that is a module which you pass to the dev, staging, and production environment. Maybe with just some slight configuration. Maybe for dev environment, you use a T2 micro. For production, you can use T3. Then version control. You have the full history of every infrastructure change. For example, the way we git add and git commit, you're making those changes. So if someone comes and deletes an EC2 resource by mistake, you can easily get back your, maybe through the Terraform files that are generated when you run Terraform plan, okay? And even through git commit, you can easily be able to track the changes that you made. So you can easily access any resource that has been deleted by mistake and rewrite it again. Then we have collaboration. Collaboration is very easy because this is, if you provision, you push the code to GitHub, your teammates can how do we call it? They can fork the repo into their computer and work on it. And also, you store your generated Terraform files for memory, like .tf state. You store them in a S3 bucket where every team member can access and also track the changes of the resources remotely. You need clarification. Then there is scalability. You can scale from one server to 1,000 of them just by changing the config, okay? You don't need to go and delete the only one server or add them manually. You just change a config and you run from 1 to 1,000 servers. There's someone whose audio is on. Kindly, if you can hear me, mute. No. So today's session, as we are looking into infrastructure as code, we are going to look at one tool, and that is Terraform. The reason why we have picked Terraform is because it's a most widely used infrastructure as code tool in the world today, and you can use it across several cloud platforms. You can use it also for on-premise to provision your resources. So you can use it in AWS, you can use it in Oracle, you can use it on-premise to provision your resources. So it's not like maybe like as a tool that can just be used for that that cloud platform. So another thing is Terraform is open source. It's also declarative configuration language. Manages state of the infrastructure. We have talked about that. Trusted by thousands of companies worldwide. And for this, you have a flexibility. If, for example, today you are working with AWS and tomorrow you get hired maybe by a company that uses Azure or GCP, and you have learned Terraform, it's just easy. It's just maybe now the name of the resources will change, but the same way you write the configuration files in AWS is just under the provider. So we have said Terraform is declarative in nature. Declarative, it means you tell the system what you want. The traditional way is maybe you log into a console, you create a VPC. You are telling it, create a VPC. You are telling the system how you want. That is, you tell Terraform what you want, and it does the rest, okay? So now we come to some of the things that you need, or things that you need to do a cloud platform account. If you're using AWS, Azure, any of them, you need an account. Maybe a free tier paid charges if you forget to delete some of the resources. And also AWS CLI, that is the command line interface for AWS installed. Then the code editor. you need a code editor like VS Code. You can also use Kiro. For myself, I mostly use Kiro. Then you need an IAM user. You don't need to use a root account, which is risky. You can use IAM. You can create an IAM user because it's through IAM user you'll be able to create these credentials that you use to configure your AWS CLI. Then you need Terraform. You need to install it in your VPC. Now let's see, installing and verifying your tools. Let me share, let's verify if I have the tools. And then let me share my screen. You can see my screen. No, I haven't shared this yet. Let me reshare my screen.
What happened? Okay.
Okay, can you see the PowerShell?
Yes. You blanked for 2-3 minutes. That's why I was looking and I was wondering what happened. Okay.
Okay, so let's verify if I have this in my PC, sorry, Terraform version. I have the Terraform installed. Then we have AWS for you to be able to configure the AWS CLI. So let's see which version I have. Okay, I do have it installed. Then are my credentials configured? Yes, my credentials are configured. We have the access key ID. We have the secret access key. We have my region configured and JSON format for document. Then let's see. Let's verify if they are truly configured. Let's get the caller identity. Yes, this is my user ID, my account, and ARN, and I will close it very fast before someone decides to do something to my account. So as we have seen, my environment is configured. So the next part, we are going to be looking at cloud resources and Terraform. We are going back to our slides, and then we'll be done in the next 5 minutes, and then we'll do a demo. So this is S instance. Kindly don't cram these resource names, okay, or resource type names, because I don't think so. Yes, that's why I was just confirming, and I have stopped sharing. Then also, you don't need to cram them because these are things that you can easily get them online. The only way is try to understand how to provision those resources. How do you write them? If you need to write to create an EC2 instance, okay, what are you supposed maybe to put in there, or maybe what kind of information do you need to create the resource? Okay, so these are things that you can easily get online, but at some point also maybe learn, if someone asks you how to provision an S3 bucket, you know the resource type name to use. Now, we are going to write our first Terraform configuration, and we are going to create a simple S3 bucket because of time, so that we can understand how do we go about it. And I'm going to be sharing my IDE so that we can do it together. Yes. Everyone can see my IDE?
Yes, it's visible.
Okay, so if you are creating Terraform resources, and now you are creating an S3, the first thing you need to tell Terraform is which cloud provider are you going to use, okay? So we are going first to create our provider block. Provider, who is AWS. And we want to create these resources in which region? We are going to create them in region. I'm going to use US East. US East 1. And also a good thing is kindly try to comment your code so that if you come back, you can be able to know this code, what does it do. First, we have created, we are telling Terraform that you're going to be using AWS as our provider in US East. We are going to create an S3 bucket. So if you are creating a resource, I've written it wrongly. If you are creating a resource, you start with the word resource. Then, which is the resource type? We are going to build an S3 bucket, okay? So this is how we are going to write the resource name, the resource type, and we're going to give it a resource name of my bucket. Now, this is the resource type name, okay? This is the resource type. This is the resource name. The resource name is an identifier that Terraform uses within your code to refer to a resource, okay? For example, if we come and build another resource that refers to S3 bucket, we will use this reference name, okay? So this bucket, let's give it a name, okay? Let's give it our bucket a name. It has given me a suggestion. My TF state, but we're going to make it unique because S3 buckets are, you need to, S3 buckets names need to be unique globally, okay? So we are going, maybe there's someone who has my TF test bucket, 1, 2, 3, 4, 5. So we are going to make it unique. We're going to use OZ, demo, TF test, bucket, demo. Yes. And then we are going to create a tag name for our bucket. I will ask a question. as we move on, maybe in the next 30 seconds, can someone tell us why we use tags when we are, why do we tag resources? Why do we tag resources? To be able to track them, yes. Yes, you can. We use resources tags to tag resources for various reasons. One is resource organization. You can be able to know. You tag your S3 buckets. You tag your, how are they called? Web servers. That is the EC tools. Then there is also security and access control. So using IAM policies, you can restrict access based on the tags. And also when it comes to cost tracking and allocation, you will be able to know a certain tag. For example, if we come to this environment, tags environment owner is also, we can be able to know which resource is using a lot of, maybe it's consuming a lot of money when it comes to the infrastructure. So you'll be able to track them, and also so you'll be able to know where your spending goes to. Now, this is enough to create an S3 bucket. Now let's look at Terraform workflow. In Terraform workflow, we start by writing the code or the configuration code, which we have done. The next thing is we initialize Terraform. When we initialize Terraform, it simply downloads the provider and the plugins that are being used for the working directory. So we are going to provision Terraform. Give it a few seconds. See. It's taking its sweet time. Okay, I don't know, it's taking time. I think I don't have enough space. I have to eat something. Can you give me like 2 minutes? I will create some space here, because it really does take a lot of space. It does. So, let's see if it's going to provision it. It has. Then we have, it says here, Terraform has been successfully initialized. So the first step, we are okay. Then we format the code. The code is okay. Then we validate if Terraform format and validate their good practice if you are creating resources. Now, let's move to Terraform plan. So we have initialized, we have formatted the code, and we have seen the code is okay. Then we plan. What is the work of Terraform plan? Terraform plan just gives you a preview of changes that are going to happen. So let's see that practically. Why can't you format the code before Terraform it? It's just a good practice. You know, sometimes you can create resources and maybe somewhere, you cannot be 100% that you did the correct formatting, okay? So it's just a good practice. So as you can see here, the plan is one resource is going to be added. That is, one resource is going to be created. There will be 0 resources to change and 0 to destroy. Let me hurry up because of time. Then we move to Terraform plan. Now this is where now we tell Terraform communicates with AWS API to provision the AWS to provision the resources. So Terraform apply. Terraform apply. We are executing or building now our real infrastructure in AWS. Terraform apply. Yes. We can see also in apply, this is the planned resources that are going to be created. So we tell it yes to provision the resources. And here we have it. Apply is successful, and we have one resource created, 0 change, 0 destroyed. Let's look at it from the other point of the AWS console. So we can move. I can go to my here. Where is it? This is my AWS console. I hope everyone can see it. And Amazon S3, let me refresh the page. As you can see, there was no bucket. There was no bucket. There was no resource. And here we have our bucket. We have our bucket, which is OZ demo TF state bucket 1, 2, 3, 4, 5. So up to that point, do we have any questions? Do we have any questions from anyone? Yes, Wadambera?
Yes, my question was, why do you format the code after Terraform init, not just formatting the code?
Okay, as I said earlier, it's just good practice, because sometimes maybe you, when creating resources, at some point maybe you forget to do proper formatting of the code. So it's just good to Terraform format FMT, that is to format the code, so that you don't incur any errors. Because if the code is not well formatted, sometimes you can run into errors because of formatting. So it's just a good practice.
Can you do it before Terraform, before you do Terraform init, or is it a must you do it after Terraform init?
That is the workflow. That is the workflow of you have to initialize first. Okay, you have to initialize Terraform.
That was my question. That was my question.
Yes, you have to do it after Terraform init. Yes, we have another question from. Okay, I don't know how to pronounce your name. Kindly just ask.
Yes, Fahri, my name is.
Yes.
First of all, for their answering for the questions or for the what
Okay.
Yes, because why we actually need to initialize the Terraform, because each Terraform needs its provider and also its resources. For instance, right now Belinda added only the S3 bucket. Let's to say if she wants to add another instance, like EC2 instance for EKS or ECR, some kind of each of these resources are requesting initializing the provider to add more additional modules for the Terraform declaration. This is the main reason. That's why we need to initialize. Melinda, my question is about the separation of the environments here. So you are directly declared everything in one main file. What about, have you tried to use a separation of the environments with the TFR files?
Yes, that is a good question. Okay, this session was mainly for beginners.
Yeah.
Yes, and I was mostly creating beginner-friendly content. But if now, let's say you are working for more advanced, those people who are using, for more advanced people who are using Terraform, I don't know how to term it, you can separate your environments.
Exactly.
And that's why I say, for example, when you're building a big infrastructure, you create modules which you pass now to your environments. That's why I was saying it's repeatable. You just create a module and then now you pass it to your environments. You pass it to dev, you pass it to staging, and you pass it to production environment. So you have the same resources. You don't have to create a dev and environment resources, then you create a staging environment resources. So you just create a module and you separate them. So for me, this session was mainly for beginners who are learning Terraform.
That's why I've actually, come back to that question to remind all the participants that there is a lot of implementations for that. And also, as Melinda says, it's not only that it's for modules, actually, it's for the purpose of the modules is for reusable.
Yes.
You can add a modules folder. Inside that modules folder, you can leverage each resources at once. And each time per environment, you can depend for the one time declared modules.
Yes.
Yeah, thank you, Melinda. I have no any questions.
Thank you so much for your intervention, and thank you for assisting me to explain that part. Thank you so much.
Thank you.
Okay. Yes. Now, I would like us to look at in the next maybe 2 minutes. We look at some of the files that are generated when we initialize Terraform. Terraform generates some of the forms, which are files, not forms, files. We have .terraform file. We have terraform.log.hcl file and terraform.tfstate file. So these files, they have different purpose, why they are generated. So terraform.tfstate is just like the memory of Terraform, okay? That is the memory of Terraform. So it is just stores the current real infrastructure that you have created, okay? Then, like the way we are saying a blueprint, this is now you can look at it as the blueprint of your infrastructure when it comes to Terraform. Then we have the .terraform file. This is generated when we run Terraform init. When you saw us creating Terraform init, this file was generated the minute Terraform init was complete. The purpose is it stores the provider plugins, okay? And also the modules that have been downloaded and the internal metadata Terraform uses to run. And this is how it looks like. So these are some of the files that are there, okay? Some you cannot open. Some of which, as you can see, the file is not displayed in the text editor because of its binary or uses an unsupported text encoding. So also we have the terraform.tfstate. As you can see, you can go through this and see the resources that we have created. Now, this is the memory of your resources. So if somebody comes and deletes the S3 bucket, you can come back here and look at the the resource that was created before. Then also, which other file? Terraform.tfstate backup. That is, for example, if we come and change our S3 bucket here, Terraform.tfstate.backup, it just acts as it's like a rollback. It has like the backup of the .tf state. Okay, so if we make any changes, the .tf state backup file is generated. So Terraform, let's look at Terraform as just Google Documents. Everybody knows about Google Documents. Now, Terraform.tf state is now the current live document. If we go to Google Documents, you have several documents. Now, maybe you have a document that stores your, let's say, something like maybe an infrastructure that you are creating, and you have maybe the architecture diagram. Okay, that is your live document. Now, the .tfstate.backup file, it provides, it gives the previous version, that is the undo option. That is where they are stored. Question: can Terraform inherit already provisioned infrastructure created manually? This is more advanced. Yes, you can. You can, but this will need a different class. Yes, you can. If infrastructure is created manually, you can provision it through Terraform. If, for example, if you get employed to a company that has been doing it manually, and now they say they need that infrastructure in cloud, what do? You'll just move that infrastructure, but you do it bits in bits. You don't just want to move the whole infrastructure. You can do it in bits and making sure that everything, maybe you move, let's say like 10 resources or maybe 5 resources today, and you make sure they're working well. Tomorrow you do for other resources like that. Yes, you can move manual to Terraform content. Yes.
Again, for the clarification for the question of other what it said, there is a Terraform import command.
Yes.
You can implement that. While if you have the same name with the same resources, exactly the same parameter, inherently adds that Terraform via the Terraform import to your TF state file, each resources. And then the TF state file will read the current infrastructure code, and then you will have the same analogy of the infrastructure in the remote site. Okay.
Yes. Yes, thank you for clarification. Now, then, away from now the demo, now we have the reasons why I that uses it. So this is just like the opposite of what we did. Maybe the problems that we get into when we are doing it manually. Now, when it comes to IaC, there is easier collaboration. We have looked at that. There is version control. You can roll back any changes, compare environments, and you can have the full history of what you have done. Then there is auditability, that is compliance teams can see exactly who changed what and when, okay? Then we have automation, zero-click deployment, CI/CD handles it from commit to cloud, and then we have reliability, okay? So we have consistent environments, we eliminate work on my machine forever. So if you're doing IaC, this infrastructure does not just work on one team member, it works across all the team members. Okay, yes, Tarak?
You have 5 more minutes.
Yes, actually we are done.
Okay.
Yes, we are done. On the last slide of key takeaways.
Thank you.
If you have to maybe leave this session today, just leave with these 5 points, okay? So leave knowing that infrastructure can be written as code, okay? Another thing is manual infrastructure doesn't scale. We have seen that. Automation is the only way forward. Then Terraform automates cloud provisioning with a simple write, plan, apply. We have done. We have seen that. Then have cloud architecture and the IaC are inseparable. We have seen that what you architect is what you build. Then IaC is an essential skill for every cloud and DevOps engineer today. Okay, because we have seen manual doesn't scale. You can learn IaC bits by bits. Okay, you don't have to learn everything in one day. Then we have the last slide. I am done. Today we have simply looked at infrastructure, how it becomes software. So a question for everyone. Terraform, can you go today, if you have never worked with Terraform, go and do a simple Terraform init in your terminal and see how easier it is or how hard it is, but do it practically, step by step, okay? Then Tarak is saying that we can continue this on WhatsApp, which is okay. See you on the WhatsApp group. If you have any questions,
we will find